In the early 20th century, physicists and chemists unlocked secrets of the atom that changed the world forever. But life remained a profound mystery. Among life's deepest secrets was inheritance. Everyone knew that traits like the shape of a pea pod or the color of eyes and hair were passed on from generation to generation. But no one knew how such information was stored. Early in his collaboration with Watson, Crick had worked out mathematically what the X-ray diffraction pattern of a helical molecule should look like. Shortly afterwards, Watson went to London to hear Franklin report on some of her recent work. When he got back, he told Crick what he remembered of her talk, and they decided to build a model. In a few days, they had one. It was a helix, with 3 sugar phosphate chains on the inside, and the bases sticking out.
At that time, the only interesting thing about the DNA molecule is the bases. And so it made perfect sense. I mean, only an idiot would put them inside, because then they're hidden.
They invited Wilkins and Franklin to come and take a look. Unfortunately, Watson had misremembered some of her key measurements. Franklin saw this immediately and quickly and derisively dismissed their effort. She went on to craft a mocking announcement for the death of DNA as a helix. It was an embarrassment that did not...
But while Crick and Watson speculate, Franklin continues to analyze and collect new information. In May 1952, she sets up the X-ray diffractometer to take an image of the wetter form of DNA, the B. In May 1952, Franklin's perseverance and exacting techniques pay off, producing the sharpest image yet of the B form of DNA. She labels it Photo 51 and puts it aside while she continues her work on the A form. But around this time, Franklin will acquire another nickname, the Dark Lady. She is so unhappy at King's, she arranges to leave. She agrees to finish analyzing her data, write up her findings, and stay until the end of the year. In the midst of this transition, someone gives Photo 51 to Wilkins. Around the time Franklin gives her last presentation at King's College, Jim Watson shows up in her office. And according to Watson's account, he implies that she is incompetent in interpreting X-ray pictures.
And as he tells us in the double helix, she began to advance toward me. And he said, fearing that in her hot anger she might strike me, I retreated, which is actually absurd. She was almost half his size.
Watson then reports that he runs into Morris Wilkins. Wilkins shows Watson Photo 51. My mouth fell open and my pulse began to race, Watson says in the double helix. It is the clear X pattern, the signature of a helix, that ignites his excitement. But there's more. Wilkins gives this crucial information to Watson. Watson sketches Photo 51 on his newspaper and reports to Crick. Based on Franklin's data, Crick and Watson go to Lawrence Bragg, the head of the Cavendish lab, and he gives them permission once again to build a model. It is Rosalind Franklin's experimental framework, a collection of evidence painstakingly accumulated over 2 years, that guides Watson and Crick to solve the structure of DNA. And in another eureka moment, the structure rewards them with the immediate realization of how DNA replicates. Now that they have discovered the secret of life, they have another problem to solve. How are they going to prove it? Once again, they need Franklin. She travels to Cambridge to review the model.
And Watson writes in his book that her immediate acceptance of the model amazed me. But she understood immediately that the model was correct. What she perhaps didn't know is how much of her data they had known in order to build that model.
Rosalind Franklin could be said to be Watson and Crick's unknowing and unrecognized collaborator.
Their triumph was reported in the journal Nature. It made headlines around the world and was celebrated 9 years later with a Nobel Prize.
That's kind of what every scientist dreams about, to make a discovery that has this kind of impact.
In 1962, James Watson, Francis Crick, and Maurice Wilkins won the Nobel Prize for their discovery of the structure of DNA. Franklin's name receives no mention, save a passing reference by Wilkins. Her crucial contribution to their work becomes a footnote in scientific history. By the time the articles appeared in Nature on April 25, 1953, Franklin had taken her new position at Birkbeck College in London. In her fifth-floor office under a leaky skylight, she often left an umbrella open on her desk to protect her papers. Here, she made what she called her greatest discovery, working out the complex structure of a virus and locating its infectious element. She collaborated with Aaron Klug, who later wins a Nobel Prize. Franklin's virus work secured her international reputation and brought many invitations to speak in the United States. In 1956, she celebrated her 36th birthday while visiting universities in California and climbed Mount Whitney, one of the highest peaks in North America. But near the end of her trip, Franklin was suffering from severe abdominal pains. On her return to England, she was diagnosed with cancer. There is speculation that her work with X-rays may have triggered the disease. Her epitaph reads, "Scientist. Her research and discoveries on viruses remain of lasting benefit to mankind." She died April 16, 1958. That same day, the London Times carried an article acclaiming her virus model, which was unveiled at the Brussels World Fair. Franklin is now receiving some long overdue recognition, plaques where she lived and worked, and recently, Britain's Royal Society created the Rosalind Franklin Award to support women in science.
For biologists, the discovery of the double helix opened up a whole new world. It was a passport to all the mysteries of life, mysteries that biologists have been decoding ever since.
The European Exomars Rover, from concept to reality. Here at the Airbus Defence and Space Mars Yard in the UK, engineers are building prototype rovers.
Starting with these two cameras at the top of the mast, they allow the rover to see in 3D in much the same way we do, and identify the rocks and the slopes in front of it, and then analyse if any are outside of its capabilities.
The rover's instruments will examine the atmosphere, and there's also a drill that can bore down to 2 meters deep. After several scientific meetings about the mission and its destination, scientists chose a former lake in an equatorial region called Oxia Planum as a landing site.
Oxia Planum is really one of the most interesting places to go with a lander to investigate, in particular with the drill cores you can take up, doing analysis of the surface material, subsurface material.
In order to search for life, every component and instrument arriving from labs across Europe is sterilised in this purpose-built clean room before assembly. The rover's wheels may have the same flexibility as rubber, but they're metal, because rubber is organic and might contaminate any evidence of life.
The big thing is having the drill so that we can actually get to the depths that we think that life would still be both alive if it could be and recognisable even if it wasn't. That's the big thing that nobody's ever really done before.
The Exomars Rover will launch in 2020. A joint mission between ESA and Russia, it will be the first rover to directly search for life.
Yes, naturally I hope that Exomars will find traces of the existence of organic compounds on the surface of Mars. And of course, Exomars is exactly the mission that should do this. It was designed for this.
ESA and Russia already has its Exomars Trace Gas Orbiter around the planet. The orbiter is sniffing the Martian atmosphere for gases like methane that might be linked to biological or geological activity. When the rover lands in 2021, a new phase of discovery will begin.